So hello everyone, welcome to this new session. Okay, so in this session, from this session onwards, we are going to solve one problems which are related to root locus. In the last session, I have discussed all the rules of construction of root locus very thoroughly. Okay, hope you have gone through that video. If you are not seen, I suggest you to please watch that video first, then come to this video and refer this video, because if you do not see that video, you cannot understand it. Okay, so please watch that video, then come to this problems video. So from now, from one session, I'm going to solve one problem, because this one problem I'm going to explain it thoroughly with all the steps. Okay, so that's why I'm going only one at a time. Okay, and I'm going to solve 5 important problems in 5 different sessions. Again, I'm telling you to please watch the full video without skipping any part if you want to understand it. Okay, and do want to write in the exam. So that's why please don't skip any part. It's my humble request to you guys, please don't skip it, watch till the end. Okay, so this is the first problem, okay, of this root locus, that is sketch the root locus plot for the given open loop transfer function that is given as g of s into h of s is equal to k divided by s into s plus 3 into s plus 5. Okay, so now we need to be going with it step by step of rules of construction. So in accordance to that, let's first try to see what is step 1. Okay, step 1 is we need to be calculating number of root loci, right? In order to calculate number of root loci, first we need to be knowing number of poles. Okay, how do we know number of poles? That is, number of poles we can see it from the transfer function only. Poles can be determined by seeing the denominator. When we equate it to 0, what we will be getting? 1. This is one pole, that is in s is equal to 0 we are having one pole. S plus 3 is equal to 0, we are having another pole, that is s is equal to minus 3, and s plus 5 is equal to 0, we are having one more pole, that is s is equal to minus 5. So we are having 3 poles here, and number of zeros, since we are not having any s variable, that is s to the power 0, so that's why we can see that we don't have any zeros in this question. So these are the number of poles and number of zeros. So if you want to, you can write the poles as well, that is s is equal to 0, minus 3, minus 5, and here s is equal to so we don't have any zeros. Okay, so this was all the first step. Now next thing is total number of root loci. Okay, so what is the formula for that? Max of number of poles number of zeros, that is max of number of poles are 3 and number of zeros are 0. So we know that max of poles zeros, we have the highest number of poles here, that is 3. So we can say that therefore number of root loci which we have in this case are 3 root loci. Okay, we are going to have 3 separate branches might be drawn in the graph. Okay, this is all about the first step. So now let's see what is second step. Step number 2, we need to be finding the total number of asymptotes. Total number of asymptotes. Okay, the formula for that is number of poles minus number of zeros, right? That is, number of poles are 3 and number of zeros are 0. So total number of asymptotes which we get is, that is total number of straight lines. We are getting it as 3 straight lines in this particular problem. Okay, we are going to draw 3 straight lines, and I also have told you, right, if we have 3 asymptotes, 3 straight lines, we must have 3 angle of asymptotes. Okay, so now the step 3 is we need to be calculating all the angle of asymptotes. Okay, before calculating angle of asymptotes, we need to be knowing the range of q, that is q is equal to, it starts from 0, 1 and it ends at p minus z minus 1, right? In this case it is 3 minus 0 minus 1. Number of poles are 3, number of zeros are 0 minus 1, that is 2. Okay, so this is the range. The values of q are from 0, 1, 2. For these 3 values of 0, 1, 2, we need to be one by one finding the angles of asymptotes. So first angle is, let me express this as theta 1. The formula I have told you, right, for theta formula is 2q plus 1 into 180 divided by number of poles minus number of zeros, right? So now that is 2 into 0. In the first case the value of q is 0 plus 1 into 180 degree divided by p minus z, that is 3 minus 0 is 3, so 2 zeros are 0, 0 plus 1 is 1, 180 into 1 is 180 degree divided by 3, that is 60 degree. So our first angle we are getting it as 60 degree. Similarly second angle 2 into, now the value of q is 1 plus 1 into 180 degree divided by 3 again. So 2 ones are 2, 2 plus 1 3, 180 into 3, that we are getting it as 540 divided by 3, and 540 by 3 if we do it we are getting it as 180 degree again. Okay, so this is the second angle of asymptote. So now theta 3, that is third angle, the value of q is now 2 into 2 plus 1 into 180 degree divided by 3, 2 2s are 4, 4 plus 1 is 5, 180 into 5 we are getting it as 900, right? Yeah, 900, if you want you can check it. Okay, so again 900 divided by 3 we are getting it as 300. Okay, so these are the three angle of asymptotes which we have found here. Okay, so now these angle of asymptotes are very important, so you can note it down and keep using these angles. We are going to construct these angles in the plot also. Okay, so now the next step is step 4. I've told you, right? After angle of asymptotes we need to be knowing from what point we are drawing those angle of asymptotes. Okay, and that point is called as centroid, right? Centroid, or it is represented as sigma. The formula for sigma is summation of real part of poles, right, minus summation of real part of zeros divided by number of poles minus number of zeros, that is p minus z. Real part of poles, how many poles we are having in this case here? 0, minus 3, minus 5. Summation of those real parts. Since we are all, in this case all are real part only, no, there are no imaginary parts, so we can directly sum it up. That is minus 3 minus 5 is minus 8, minus real part of 0. Since we don't have any 0, we can write directly as 0 divided by p minus z. Okay, that is also we can directly write it as divided by number of asymptotes. P minus z is a number of asymptotes, right? So number of asymptotes are 3, so therefore minus 8 minus 0 is minus 8 by 3. Okay, so now if we solve this minus 8 by 3 in the calculator, we put the minus 8 by 3 in the calculator, that is 8 by 3, we are getting approximately as 2.6667, or we can write it as minus 2.67. so this is the value of our centroid. From this point we should plot this point in the graph, and from this point we are drawing all the angle of asymptotes. Okay, hope you understood. So now let's get to the next step. So next step is breakaway point. For that we need to be calculating the characteristic equation by computing 1 plus g of s into h of s is equal to 0, right? Firstly, the first step for calculating breakaway point, for determining breakaway point, this is the first step. Again, that is 1 plus, in the question substitute the value of g of s into h of s on the question, that is k into s into k divided by s into s plus 3 into s plus 5 equal to 0. Take the LCM, that is s into s plus 3 into s plus 5 plus k equal to 0. Since if we divide this term again and if we cross multiply again, we are getting it as 0, so I am writing it equal to 0. Then again cross multiply this, s into s plus 3 is s square plus 3s into s plus 5 plus k equal to 0. Then s square into s is s cube, s square into 5 is 5s square, 3s into s is 3s square, 3s into 5 is plus 15s plus k equal to 0. So therefore our transfer characteristic equation we are getting it as 5s square plus 3s square is 8s square plus 15s plus k equal to 0. Okay, so this is the characteristic equation. From this we have obtained, that is CEQ, and from this we need to be obtaining the value of k, right? For that thing what we need to doing, bring this k to one side, that is k is equal to all these terms, bring it to other side, that is all this term would be becoming negative now, that is minus s cube minus 8s square minus 15s, right? Now the next step is dk by ds is equal to 0, right? Apply that, that is dk by ds, that is we need to be taking the derivative of this term. Derivative of minus s cube is minus 3s square, derivative of minus 8s square is 8 into 2s are 8 2s are 16 minus 16s my derivative of minus 15s is minus 15. Okay, that is equal to 0. So now the equation which we are getting is minus 3s square minus 16s minus 15 equal to 0. So we can take this minus common outside, minus of 3s square plus 16s plus 15 equal to 0. So we can cancel this 0 out if you bring it to other side. So therefore 3s square plus 16s plus 15 equal to 0. Okay, so now for this equation we need to be finding the roots. Either we can use the quadratic formula, that is minus b plus or minus b square minus 4ac divided by 2a, and find the roots, or in order to avoid time waste, we can directly substitute this equation in the calculator only. I would be telling you how. Some of you might be knowing it, those who are very good at maths and thoroughly following the maths. So what to do in this case is, in order to find its roots, first go to mode setup, okay, and go and there in this option they have mentioned equation, right? For equation, this is for 991 ES version, okay. Those who are having this calculator, you can try this 991 ES or 991 MS, okay. Then go to that equation, press 5. Then again we are having few of the options. Then here it is of the form of ax square plus bx plus c equal to 0, right? That is 3s square plus 16s plus 15. That is of number 3 here. Again we need to press 3. And here we have the matrix form, that is a, b, c. That is, we need to be substituting the coefficients one by one. In place of a, substitute the coefficient of s square, that is 3. Here write 3 and press equal to symbol, okay. If we press equal to, this 3 value would be loaded here. Same, it would be going to b. Again the b means coefficient of s, that is 16. Again press equal to, and 16 would be loaded in the value of b. And same goes with 3, c, that is substitute the value of here 15. Okay, press equal to, and all these 3 values would be loaded here. Now again press equal to. After that we would be getting 2 roots, okay, that is x1. This is the value. If you want to convert it into decimal, press this s cross d, okay. Here we would be getting the first root. So write the roots here, roots minus 1.213 comma the second root. If you want to take the second root, again press equal to. So this is the second root, again press this minus 4.11, okay. So these are the 2 roots here, okay. So now in these 2 roots, we need to be checking what is the valid breakaway point, okay. For that thing, again we need to be checking the plot, right? So now let's check it here only. So I will be drawing one simple plot here only. So the 3 poles are 0, minus 3, minus 5, that is 0. This is 0. So somewhere here it will be getting minus 3. This is the pole. Somewhere here I will be getting minus 5, okay. So now let's here I will be getting minus 5. 0, minus 3, minus 5. And roughly I have drawn it here. This is the real part, real axis. This is the imaginary axis. In order to check which is the valid breakaway point. So how to check it? That first we need to be checking that breakaway point is a part of root locus, okay. That is, from this point, check to the right hand side, we have one pole, that is odd number. So this is the part of root locus. And from this point, if we check it to the right hand side, we have 2 poles, right? If you look at the right, so we can say that this is not the part of root locus, okay. But the value, we have got one value as minus 4.11. It lies in this region. So this is the invalid breakaway point. And this minus 1.213 lies in this region. Since this is a part of root locus, so this is the valid breakaway point. So therefore our breakaway point which we are getting is equal to minus 1.213. This point we need to be plotting in the graph, okay. So that I will be showing you while I plot the graph. So now let's get to the next step. So this is the next step. We need to be finding the value of point of intersection on imaginary axis, right? Whether we have any point of intersection on imaginary axis or not, okay. But before this we had one more step, right? If you recall it, the step is to find the angle of departure, but it's not required in this case because the poles mentioned here are real poles, okay, not imaginary poles or complex poles. So we don't need to calculate any angle of departure for that, okay. So directly let's skip that step and let's go to the last step, that is intersection. So in this case, use this equation and draw the Routh array, okay. So I'm going to do this very quick since I've discussed it a lot of times. So write the coefficient s cube, s square, s power 1, s power 0. Coefficient of s cube is 1. Skip one term, write the coefficient of s 15. Skip one term, it is 0. Coefficient of s square is 8. skip one term, k 0. Using these two rows, try to calculate the third row elements. 15 8s are 120, minus 1 into k is k divided by 8, and again this is 0, and again 120 minus k by 8 into k, minus 8 into 0 is 0, so that's why divided by this term, so we can cancel numerator and denominator by this term, so the remaining answer is k only. Okay, so this is the row array I have constructed here. So now what is the next step? K greater than 0, so that's why the above row, that is 120 minus k is replaced by k margin now. Okay, in order to represent the row of zeros, we need to equate that equal to 0. If we equate this term to 0, we would be getting one row of 0. From this row of 0, we would be getting auxiliary equation, and that auxiliary equation we can find the s value. So now this, if you take this 8 to other side, it will be 0. So 120 minus k margin equal to 0. So therefore our k margin value, we are getting it as 120. Okay. So now substitute this k margin value in the auxiliary equation. Next step I've told you, right? We need to be equating a of s is equal to 0. The a of s is the row above the row of 0, the equation, that is 8 into s square plus k, so that is replaced by k margin equal to 0. So 8s square plus k margin value, I have found it as 120 equal to 0. So 8s square is equal to minus 120, s square is equal to minus 120 by 8. Okay, that is 8 1s are 8 15s are, so s square is equal to minus 15. So s is equal to plus or minus square root of minus 15. Okay, if we have, since we have here minus 15, so s is equal to plus or minus j. Since in order to take this negative sign, we need to be adding I square or j square, it's one and the same, and square root of it, j square is j, so I have written j, and square root of 15. Okay, square root of 15, we are getting approximately 3.87. okay, 3.87. okay, so these are the points of intersection on the imaginary axis, that is plus 3.87 j and minus j 3.87. okay, in the imaginary axis part, we need to be plotting these 2 points. Okay, so this is all about the theory calculation part. So now using these calculation values, let's try to plot the root locus. Okay, so here I have drawn the root locus graph here. Okay, so this is the imaginary axis part and this is the real axis part. Okay, and I have given the values of imaginary axis of plus and minus, and here all the values of minus, since this is the second quadrant. Since most of the root locus which we are getting is on the second quadrant only, so that's why we can draw directly the graph of second quadrant only by highlighting the second quadrant part. So we don't need the real part of which we are having plus values, so directly we can skip this and we can plot only second quadrant. So first thing is plot the zeros and poles in the plot graph. Since you don't have any zeros, so directly plot the poles. One pole is at 0, other pole is at minus 3, right, and other pole is at minus 5. Okay, so these are the 3 poles here which are plotted. We're using the X mark, I've told you. Now plot the centroid. Okay, centroid from the problem which we have got is minus 2.67, that is the centroid, right? So let's try to plot that centroid here. Centroid here, it is, this is 2 and this is 3, so this would be 2.5, just close to 2.5. this might be one centroid part. So mark this point, highlight this point and name it as sigma. Okay, so this is our centroid. Okay, and now from this centroid we need to be marking the angle of asymptotes. Okay, use one protractor, keep the point here and mark the angle of asymptotes. The 3 angles are which we have got in this case is 60, 180 and 300, right? So now let's plot those 3 angle of asymptotes. Okay, keep the protractor here, mark one as 60, one is 180, means this is one angle, and from down, okay, plot one 300 degree plot, that is from this side mark plot 60, since the whole angle is 360 degree, so that's why from this side if I mark 60, so automatically this whole angle will be 300 degree. Okay, then join that line, that is we need to join the straight line which is called as asymptotes. Okay, by the dotted lines. Okay, from this point and this point join the lines. These are the lines, the straight lines or the asymptotes. Okay, one is this and one is from here. okay, one is here, okay, we have three asymptotes, one is 180 degrees, so that's why we have one more asymptote here. So then mark the angles, one is 60 degree, one is 180 degree, and the other one is 300 degree, right? Yeah, so in this way we have plotted even the asymptotes and the angle of asymptotes. Now let's plot the breakaway point, okay. So in this case breakaway point we have obtained is minus 1.213, right? Since 4.11 is invalid because this is not the part of root locus, right? Only this section is a part of root locus, okay. So I am highlighting here, this is the part of root locus section here. Since from this pole, since we have only one pole, odd number of poles, so this is not the section of root locus, and this section is also a part of root locus only. From infinity, if we see, we have three poles, right? So that's why this section is also a part of root locus. Okay, so now in this section try to plot minus 1.213. so if this is minus 1, this is minus 1.5, this is minus 1.25, so somewhere here would be our breakaway point. So write it as minus 1.213 and highlight it. Okay, so now let's try to plot the root locus branch. Okay, for that thing what we need to be knowing is, since we have three poles here and between two poles we have one breakaway point, so we can see that these two poles here would be approaching towards the breakaway point. Okay, if we have a breakaway point between any two poles, we can say that these two poles are approaching towards breakaway point. That is, from this pole one branch is moving in this direction, okay, and from this pole one branch is moving in this direction, okay, and from this pole, since we don't have any breakaway point but we have an angle of 180 degree, so we can say that this pole is approaching towards infinity. Okay, so this we have here one more branch, okay, and this pole is approaching towards minus infinity. Okay, but if it approaches towards the breakaway point, it should be it should spread. Okay, it should be moving in a direction and it would be meeting the point of intersection. Okay, so point of intersection in this case we have got it as plus or minus j 3.87. so plot that also first. 3.87, it might be coming somewhere here. This is plus 3.87i and this is somewhere here minus 3.87i. Okay, so now what would be happening is, from the pole it is moving towards breakaway point, and when this branch reaches the breakaway point, it emerges like this, it goes like this. Okay, same with here, and from this here it moves in this direction now. Okay, and same with here, from this from this pole it is moving in this branch, and from when it reaches the breakaway point it goes down like this. Okay, in this direction. Okay, and now this root locus bends at an angle of 60 degree. Since we have an angle of asymptotes of 60 degree with the line of asymptotes, it would be following that line only, and it would be bending in the same line. Okay, and it would be moving towards the point of intersection, that is plus 3.87i, and it would be approaching to infinity. Same goes with here. Okay, from this it would be bending at an angle of 300 degree. Okay, approaching seeing the straight line parallelly, it would be going, and it would be going to the point of intersection of plus minus 3.879. it would be touching that, and it would be going this also, it would be going towards infinity. Okay, so this is the simple root locus plot. Okay, like this we need to be plotting the root locus here. Okay, that is, from these two poles one branches are going, it meets the breakaway point, and from this pole it is meets the breakaway point, and it bends at an angle of 60 degree and intersects at point plus 3.879. From this pole one branch is going, it meets the breakaway point, bends at an angle of 300 degree and touches this intersection point, that is minus 3.87i. Okay, and goes towards infinity, and here also it goes towards infinity. Okay, since we don't have any zeros here, so any pole would not be approaching to zeros, so that's why all the poles at the end of the day from the branch, it would be, if there is any breakaway point between any two poles, it would be going towards that breakaway point, and it would be diverging it towards infinity. Okay, since here we don't have any breakaway points, okay, so that's why we don't have any branch here, so this is directly going towards minus infinity, because we have one certain angle here, right, 180 degree, and one line of asymptotes. So that's why it would be following that line of asymptotes in the straight line and it will be moving towards infinity. So these are the three branches here, and this is one simple root locus plot. So hope you understood this. Okay, so please like, share, subscribe, and try to solve this problem. Refer this video and try to solve this without seeing. So that's all. Please refer our playlist and for previous videos, and please refer our rules of construction of this root locus, which we have done just about previous this video. So please refer that as well. So that's all. Thank you.